How's everyone doing? How's everyone doing? Do you guys need another minute?
Yes.
Okay. No, I'm just saying. Alright, can I work through this? Yes. Alright, step number 1 is finding the mean. So the mean is 11. Is that okay with everyone? Anyone have trouble getting the mean to be 11? Okay. Do not use the median. If you use the median, you use 12. That would give you the wrong answer. Perhaps by coincidence it might not, but you must use the mean. And our mean, x bar, is 11. You add up the 5 numbers, divide by 5, you get 11. Good?
Wait, what? Repeat that again?
The mean is 11.
The mean is you add everything up.
You add up the 5 numbers, you get, alright, if I add up these, I get 55, and I divide by 5, and I get 11.
The other one that's like the n plus 2 over...
Do not use the median.
Oh, n plus 1.
Do not use the median.
Okay.
Just follow the directions, alright? If it says find the median, find the median. Okay, don't use the median. The median is not what we're going to use. What if you did it wrong? Okay. It's non-negotiable. You must use the median. Alright, be quiet now. Now we find the deviations from the mean. My deviations are... Okay? Right? Square these. If I square these deviations, and make sure that whenever you square something, you get a positive number. Those are my squared deviations. Did everyone make it this far?
With wrong numbers.
Somebody went wrong? Alright, and then you add all of these up, and if we add all of these up, we get 58. Everyone make it that far? So it's not a hard step, you just have numbers to add, and you add them up, and you get 58. And then what do we do? Divide by n minus 1. So what is my n? My n is 5, I have 5 numbers, n minus 1 is 4. 58 divided by 4, and that gives me 14.5. If I stop at 14.5, what is this?
Variation.
This is the variation, but I don't want the variation, I want the standard deviation. So I do 14.5, take the square root of that, and I get 3.808. So my standard deviation is 3.808. Yes?
Okay, I have a question. So how do you find the mean? The mean, you add up all the numbers and then divide it by how many numbers there are?
Yes.
So how come on that one the mean is the middle number?
The mean, by coincidence, because of the numbers I selected, by coincidence, the mean happened to be equal to the median. Okay? I think I mentioned that I regret choosing these numbers, but that's just what happened. And I regret choosing these numbers exactly for that reason, because some students might be confused about it. So the mean, we add them up, and we divide by however many numbers we have. Okay, so next week on the quiz, if I give you several numbers and say find the standard deviation of these numbers, everybody is going to get 100%?
Yes.
Good. When we have the standard deviation, listen up. When we have a standard deviation, we can use the standard deviation to find basically a standardized distance, okay? So perhaps someone going to SMC says, oh, my life is so hard, it takes me 45 minutes to get to campus. Okay? And maybe someone over at LMU says, you have no idea how hard my life is. It takes me 20 minutes to get to campus. And 20 minutes doesn't sound like much, but at LMU that's a lot. My life is terrible. Okay. Who is more unusual? That's the question, okay? Should we feel bad for the LMU student who takes 20 minutes to get to campus? Should we feel bad for the SMC student who takes 45 minutes to get to campus as compared to the other students? Okay. Well, let's say this is the standard deviation for commute times at LMU. Okay, and let's say the average commute time is 11 minutes. And the standard deviation is equal to 3.80 meters. Student complains. About his 20-minute commute. How unusual is a 20-minute commute for LMU? Okay. What we can do is we can figure out how different his commute is from average, but not just in terms of minutes, but in terms of the standard deviation. So, how much longer than average is this person's commute? It's 9 minutes longer than average. You see that? His commute is 20 minutes, the average commute is 11. So his commute is 9 minutes longer than average. A standard deviation is 3.808 minutes. So how many standard deviations away from the mean is his commute time? Okay, well I would do 9 minutes divided by 3.808. So this is called calculating a z-score. A z-score is how many standard deviations we are from the mean. And I'll write the formula for this because I think students actually prefer the formula for finding the z-score. But you must know this definition. Put a star. I'm so nice. I'll just tell you the things you really need to know. So z is given by x minus the mean, which is x bar, divided by the standard deviation. So in this particular case, the z, we take the man's commute of 20 minutes, subtract the average of 11, and we're going to divide by 3.808, and we get 2.36. So the man's z-score for his commute time is 2.363. So he is 2.363 what? He is that many standard deviations away from the mean. This man's commute time is 2.363 standard deviations away from the mean. As a rule of thumb, anything that is more than 2 standard deviations away from the mean, meaning the z-score is larger than 2 or more negative than negative 2, can be considered unusual. And if it's more than 3, you can consider it highly unusual. But in general, things that are more than 2 standard deviations away from the mean can be considered unusual. This will be a topic that comes up again when we talk about the normal distribution. That as a rule of thumb, more than 2 standard deviations away from the mean Okay, what about the other student? The other student has a 45-minute commute. To SMC. And we saw that the average commute to SMC is 27.5 minutes. And the standard deviation is, what was it, 14.43 or 14.43 minutes. Find the z-score of this person's commute. This person has a 45-minute commute. What is this person's z-score?
You just grabbed it. You would never have, well, the formula is obviously less up. You would never have the average in front of the value. Or like it wouldn't be x bar minus x other.
Okay, so we get z is equal to 1.213. Are there issues with that? Did everyone get this? Who did not get this? Okay.
I'm still in the
Okay. So the formula looks like this. What is x?
45.
Okay, I'm asking the student. Okay. So do we know what x is?
Oh, 45.
45, right? That's the value that we are interested in. What is x bar? I'm sorry, what's your name?
Mars.
Mars. Okay, so Mars, what's our x bar?
27.
27.5, that's the average. Yes, that is correct. And what is S?
2.
No, S is not 2.
Oh, 14.5.
S is our standard deviation, 14.43. And if you plug these values in, so what is the first thing that you do in the calculator? When we do order of operations, what do we do?
45.
Yeah, I do the numerator, I calculate what the numerator value is, and I get 17.5, and I divide that by 14.43, and when I do that, I get that. 1.213.
Just curious, can we abbreviate, or do you want us to write it out, like, like standard deviation of C, or like mean is just the X bar, maybe like that,
You can write X bar.
Like-
I don't know if I understand what you
like,
mean.
I don't know how the quiz is obviously, but if you want us to like write it out.
I think it's clear what you have to do on the quiz and
Okay.
do what is asked of you.
So that would be considered a very usual.
It would not be considered unusual. Okay? Yeah. So, all right. So, does the student at LMU have any credence to his claim that his commute is so terrible?
Yeah.
Yeah. Okay. He's more than 2 standard deviations away. If we're comparing these two students, this person's commute is only 1.2 standard deviations away from me, and this person's commute is indeed larger than that, 2.36 standard deviations away from the mean. So a student saying that his commute time is greatly different from me over here would be justified in doing so. Yes. Okay, so if we are comparing, so by using z-scores, which tells us how many standard deviations we are from the mean, we can compare quantities from different groups. We can say this is an unusual commute time, or, this is unusually large for this species of dog, okay, or this breed of dog, right? Is it unusual to see a 30-pound dog? No. But if I tell you it was a 30-pound Chihuahua, you'd say, whoa, okay? And that is because the distance from the mean is very large compared to, is very large from the standard deviation, okay? So what do we have left? We've talked about the mean, we've talked about the median, we've talked about the standard deviation. Now we have to talk about measures of spread, such as the range and the IQR. And again, these might be the preferred measures of spread for skewed data sets. The range is very simple. The range is the distance from the largest point to the smallest point. So you take the maximum minus the minimum. This is the distance from the largest to the smallest point. So let's say I've got some data, and we're going to use this data for finding the quartiles and things like that also. I'm going to arrange these from smallest to largest already, skipping a step. But don't think that that step is unimportant. I'm doing it now to save us some time. Okay? So the premise for this data is that, let's say I took 14 seeds and I planted them. Okay, and I watered these 14, I don't know, seeds of corn or something. And I just wanted to see how much did this stuff grow in like a 1 week period. Okay, so I measure how how many millimeters or centimeters this stuff grows, and let's say these measurements are as follows. Okay, so 5 centimeters, 6 centimeters, 6 centimeters, 7, 7. So those are my, I think I have 14 values there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And if you are in the back, I will call them out. They are 5, 6, 6, 7, 7, 8, 9, 9, 9, 10, 11, 12, 22, and 25. So what is the range here? 20 centimeters, okay? I take the maximum, my range is equal to 25 minus 5, the max minus the min, I get a range of 20. So far so good, yeah? Okay, so that's the range, easy enough. Let me talk about quartiles because we're going to talk about the interquartile range, which depends on finding the quartiles. There are 4 quartiles. So you see the word quart in there, like quarter. There's 4 quartiles, Q1, Q2, Q3, and Q4, although the only ones of real interest to us are Q1 and Q3. The quartiles are defined in such a way that 1/4 of the data is smaller than Q1, 2/4 of the data are smaller than Q2, 3/4 are smaller than Q3, and 4/4 are smaller than Q4. Does that make sense? No? All I'm doing is I'm just lining up spots here, okay? So Q1 is some number where 1/4 of the data is smaller than Q1. Q2 is another spot. Is it bigger or smaller than Q1? It's bigger than Q1 because 2/4 of the data are smaller than Q2. How much is smaller than Q3? 3/4 are smaller than Q3. And how much is smaller than Q4? 4/4. We have another name already for Q2, and what is that? The median. The median, okay? Q2, I said 2/4 or half of the data is smaller than Q2. Is that concept okay? And how much of the data is smaller than the median? Half of the data is smaller than the median. You guys are going to make me cry. Go home and say, oh. Alright, so Q2 is equal to the median. 2/4 or half of the data is smaller than Q2. Okay? Is that okay? And what is another name for Q4?
Largest number.
The maximum, the largest number. Thank you. Okay, the maximum. I don't know if this says a mode, but I want to punch you in the face. I'm kidding. Q1. So Q1 is also known as the 25th percentile because 25% is smaller than Q1. So 25% of the data is smaller than Q1. What percentage of the data is smaller than Q3?
75%.
Yes, thank you. I can sleep tonight, okay.
So,
is that okay? Alright, good. So how can I go about finding Q1 and Q3? Well, when I have the set of data like this, already arranged from smallest to largest, if it's not already in order, you have to do that. It's step one, most important step. The first thing I'm going to do is I'm going to find the median. The median tells me the spot where half are bigger and half are smaller. That's going to divide my data into two lists, a larger half and a smaller half. I'm going to take each of those halves and then find the median again, because half of a half is a quarter. Does that sound good? Okay, so let's see if you can do that without much guidance. Now actually, in the interest of time, I'm going to just do it. So, I have 14 numbers. Where is my median located? What is the position of the median of this set of numbers?
9.
Okay, so finding the median, if the number in the n plus 1 over 2 position, so how many n, how big is my n? 14. So 14 plus 1 over 2, it's going to be the number in the 7.5 position.
9.5.
Yeah, okay, so I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. What is my 7th place number? 9. What's my 8th place number? Okay, so what is my 7.5 number? 9. My median is in between 9 and 9, so my median is 9. It's not 9.5, it's 9. Okay, so my median goes right here, and it splits my data into two halves. I have 7 numbers that are smaller than the median, 7 numbers that are larger than the median. Okay. Technically, these 9s are all equal to the median, but we're going to split these as these are larger and these are considered smaller. Are we good? Okay, so to find Q1 and Q3, I'm now going to take these 7 numbers and just find the median of these 7 numbers. So what's the median of these numbers here? 7. It's the number, the 4th place number. So that is Q1. Did I do that too quickly?
So you split it in half.
Right, I just did this. No. And that is an equally valid way to find the median, but I have 7 numbers. Okay, so just, you're going to pretend like these other numbers don't exist. I have 7 numbers, and I'm saying find the median of these 7 numbers. And what is that? Do you have a question?
Yes. So the median would be Q2, in other words. Yeah. So Q1, Q2. And
Yeah, the median, this 9 is Q2, that's correct. The median is always Q2, just FYI. Q4 is always the maximum. And so with these 7 numbers over here, I'm finding the median, and that's Q1. Okay? I do the same thing over here.
11.
Q3. So over here I have 7 numbers, and I'm going to find 7 plus 1 over 2, the 4th place number. 1, 2, 3, 4, 11. Finding Q1 and Q3. Good? No?
Yes.
You don't understand anything? Yes, yes. Okay. Finding a median, 9. Is that okay? Yes. Okay. So, essentially, all right. I'm going to take these 7 numbers that are smaller than 9. Okay? I drew the median right here. I drew the line right here. And I'm going to take these 7 numbers that are smaller than that. Where are my 7 numbers there? 5, 6, 6, 7, 7, 8, and 9. Okay? Do you have that in your notes? Okay. What is the median of these 7 numbers? Do we know how to find that? Yes. That's all I did. Okay. And I did the exact same thing over here. Okay. So I found the Q1 and Q3. Those are my quartiles. Next week, if on the quiz I give you a bunch of numbers and I say find the median in Q1 and Q3, you can do that? Yeah. Good. Every now and then there's someone yelling no, and I'm. Alright. Okay, so the IQR is defined as the interquartile range. Hang on. I still have you for 10 minutes, okay? IQR is defined as Q3 minus Q1. So the range was the maximum minus the minimum. The interquartile range is Q3 minus Q1. So I do 11 minus 7, and I get an interquartile range of 4. And just like the standard deviation or any other summary statistic number, these numbers in of themselves, by themselves, aren't very meaningful. However, if I gave you another set of data and I say, so here are the numbers that, the growth numbers for corn, and then I tried growing some lima beans. Okay, I grew 14 lima beans, and this is how much they grew. By comparing the range and the IQR, you can get an idea of the spread. If I told you the range in growth of the lima beans was 6, and the range over for the corn was 20, what does that tell you about the range for the lima beans? Or
There's less spread.
less spread, okay? So when I grew the corn, I've got short corn, I've got tall corn, I've got a wide range in how tall my corn grew, okay? With the lima beans, if the range is 6 and the corn is 20, that tells me that however tall the lima beans grew, they all kind of grew very similar to each other. Okay, I don't see a huge discrepancy in the heights. That's what that tells us. Same with the IQR. The IQR is another way of describing spread, except the range is the great difference here is that the range is affected by extremely large and extremely small values, whereas the IQR is not affected by the extreme values. Yes?
So, since we have an IQR of 4 and a range of 20, what can we conclude?
In of themselves, these summary statistic values are not useful. They are only useful when in the context of comparison. Okay? You've got to know how to find the IQR, you've got to know how to find the range, but they are only useful in the context of comparison. If I tell you this man had this guy took a test and his score was 603, does that mean anything to you?
No.
No, you have no idea what 603 is. If I tell you that the average score is 500 and the standard deviation is 40 or something like that, and most people only score between whatever, 400 and 550 or something, then you go 603, wow, that's really high or something, okay? So only in the context of comparison. Yes? I'm sorry? Q4 would be 25, yes. Okay. Alright, please don't pack up yet, okay? Just, the class goes till 10, just stick with me till 10. Please be respectful and not pack all of your stuff up yet. So here's the IQR. There is another graphic display called a box plot. Okay. And a box plot looks like this. There's a box with a line somewhere in it, and lines coming out of the box. Sometimes there's even circles. Great. The box is defined by Q1, Q2, or the median, and Q3. If you see circles, or stars, sometimes they're stars, but if you see circles, that means these data points, these are part of the data, but they are considered outliers. Okay? So this is still part of the data, but they are considered outliers. Quick question. How much of the data is between here and here? What percentage of the data? 50%. This is the 75th percentile of Q3. This is the 25th percentile. How much is between the 25th and 75th percentile? 50%. Half of the data is in between here. How much is in between the median and Q3? 25%. How much is smaller than Q1?
25%.
How much is bigger than Q3? Okay, how much is bigger than Q1? 75%. Okay. So, again, box plots, they are kind of visual summaries of, all of these things, the quartiles and the median. And it's just kind of like this bare bones essentials summary guide of the data. Okay?
It's
Yes.
slightly, it's in the middle though, right? Not all the way to the side like that.
The median?
Yes.
No, the median does not have to necessarily be halfway between Q1 and Q3.
It's not, it won't be drawn that way.
Not necessarily. It depends on the data. The median is the halfway point. Half are bigger than the median, half are smaller than the median. That may not necessarily be exactly halfway between Q1 and Q3 in terms of the values. Okay? Okay, so in your homework, you'll have some box plots to look at and things like that. Let me talk about the quiz next week, okay? Come to class on time. I'm going to pass out the quiz at 6:45, and you'll have half an hour to complete the quiz, which means it ends at 7:15. If you come late and you show up at 7:10, you will have 5 minutes to take your quiz. You are responsible for bringing your own calculator and your own pencil. You cannot borrow someone else's calculator. If you forget your calculator, I'm going to say, I'm sorry, do your best. Okay? So make sure you have a calculator. You are allowed a note card, a 3x5 note card, on which you can write notes, example problems, formulas, pictures, encouraging notes to yourself. Double-sided is fine. 3x5 note card, okay? I don't want to see a 6x8 note card and you call me, it's a note card, okay? 3x5 note card, no exceptions. If I'm walking around and I see a note card that is larger than 3x5, I will take it away and you will have no note card, okay? If you are too cheap to go to the store and buy yourself note cards, you can take a piece of paper, measure 3 inches by 5 inches and cut that out. That is fine, okay? But make sure that when you cut it, it is indeed 3x5. You will have half an hour. You are not allowed to share note cards. You're not allowed to share anything during the quiz. When you arrive next week, I'm going to ask that you all sit so there is at least one open seat between you and your neighbors. So what's going on in this back row is not going to fly, okay? There is enough seats for everybody. If we have to, I will allow students to sit next to each other in the front row, but I think there is enough seats for everybody to sit with at least one open seat. We have a question.
Can we bring our Should we bring our own scratch paper or?
No, do all of your work on the quiz itself, no scratch paper. There shouldn't be a need for scratch paper. Yes? Your class starts at 6:45. It started 6:45 this week, it started 6:45 last week. I don't know what else to tell you. Yes? It's written for half an hour. I don't know, it's maybe, it depends from quiz to quiz. It's one page front and back. Okay? It's plenty of time. Yes? Huh? I have described exactly what you need to know for the quiz on the homework page for this week. Okay? All of your questions should be answered there.